so at the top of the page, we're going to fill in some definitions real quick. So if it's exponential growth, what does your graph look like? Is it going up slowly, steadily? Goes up really fast. So it gets really big, really fast. Fastly? Is that what we said? I don't think so. Quickly. You could say quickly. Goes up quickly. And that B value, so the number inside your parentheses, do you remember what it has to be for growth? So your B value's got to be bigger than 1. So what is it going to be for decay? And remember, it's not going to be negative, so it's technically between like 0 and 1, but it's just a fraction less than 1, or a decimal most of the time. And then for decay, what's your graph going to look like? Goes down really fast. Is that alright? We good with all that? So today's kind of going to be a bunch of reviews, so a bunch of the same stuff over and over again, but that's okay, and we're going to add just a little bit more. So for exponential growth, it's given by the equation. Do you remember the equation that gives us our exponential growth and decay? Y equals A parentheses. I'm pulling this from the homework that you did last night. 1 plus R to the T, or to the X. This one's got an X in it, not a T. To the X. Is that okay? Yeah. All right. So what does that A stand for? That part's easy. Initial amount, or what else might they call it? Principal. So B, we didn't write a B here, but what do we put in place of where B is? Plus what? R. So it's going to be whatever is inside your parentheses. I don't know how to spell parentheses, so I'm just going to draw them. Is that okay? So your B value is whatever's inside your parentheses. And we call that your growth factor, or your decay factor if it's decay. So I'm just going to write growth factor because this is specifically talking about growth. So your growth factor is when we've done 1 plus that rate. If it asks for your growth rate, that's just the percent that it's either increasing or decreasing by. So for X, we're going to put independent variable. And what is X usually for us? Some measure of what? Time. So then Y is going to be your dependent variable, and it's been like money or population. I think that's about it for these problems, right? I don't think we've had anything else. So, I want to add one more thing. For the R, we said that the B is your growth factor, so I want to label the R as our growth rate. And we're going to write it as a decimal today. So yesterday you just used that percent button in your calculator, and that's fine. But I think we're a little bit smarter than that, so we're going to try to stretch just a little bit further and go ahead and write that as a decimal today, okay? Questions on anything so far? All right, so we are gonna go ahead and get started then. So for the example 1, it says in 1971 there were this many females participating in high school sports. Since then, that number has increased an average of 8.5% per year. So we want to write an equation to represent the number of females participating in sports since 1971. So we're gonna have Y equals, because that's always gonna be there, and then we're supposed to have our A value. And what does A stand for? And what is our initial amount here? That big number, 294,105. I just hate reading numbers. And then inside parentheses, we're supposed to have 1 plus our growth rate. So we can break this down, or we can do it all in one step. What do y'all want to do? Is all in one okay with y'all? Okay, so we've got to do 1 plus our rate. So we can go ahead and convert that percent to a decimal. How would you do that? Move your decimal which way? To the left twice, right? So that's going to be 0.085. When we add 1 to that, it's just going to be 1.085, right? So 1.085. That's going to go inside our parentheses. And it's going to be to the x. Questions there? Alright, so tell me, what is the growth rate? Now remember your rate. Your rate is just the percent. So that would be 8.5%. We'll put it as a percent. And that would, what would the growth factor be? So remember, the growth factor is after you've added or subtracted 1. So that's going to be 1.085. So we're going to do that every time so that we get very familiar with which is which. Okay, so just remind me in case I try to skip it. Yeah. Is that alright? So the rate is your what? Percent. And the factor is after you've added or subtracted 1 to it. Yeah? So whatever is inside your parentheses. Questions? So for the next part, it says how many females participated in high school sports in 2008. How are we going to figure that out? Well, we got to figure out how much time has passed from when we started to 2008, right? So how are we going to do that? Subtract. So 2008 minus 1971, what do we get? Type that in your calculator real quick. So x is 37. So we're plugging in 37 for your exponent. Yeah? Alright, so we got 294,105, parentheses 1.085 to the 37. So let's type that in our calculators and see what we get. So what happens? We got that E. Do you remember how to handle that? Arrow up, hit enter, and that's going to tell you what number we're actually looking for. So this is talking about people, right? So let's round this to a whole number. What can we put? I got 601,7314, but it's 4.6, so we should put 1.5. 6,017,315. Yep. I have to like go backwards and put in my commas, and then I can figure it out. Sometimes. Hate reading numbers. We okay? Questions on anything? So we're all okay? Yeah? Alrighty. Okay, so for number 2, it says the population of Johnson City in 1995 was 25,000. Since then, the population has grown at an average rate of 3.2% each year. So can we go ahead and say what our growth rate is? 3.2%. They're probably going to write that as a decimal, so what would it be as a decimal? Is that alright? Let's start doing that. Let's write it in a decimal every time I click it in. And then your growth factor. We know that the population is growing, right? So it is indeed growth. So we're going to have to add 1 to that number. So 1 plus 0.032. What do we get? 1.032. Is that alright? So we're going to write our equation. So you're going to have y equals, and then what do we put? Where are we putting 25,000? Your initial, whatever you're starting with. Inside parentheses, what do we put? 1.032. Your growth or decay factor goes inside those parentheses. And it's got to be to what exponent? X. Because we're just writing our function right now, so we don't know what to plug in yet. Questions there? All right, next part, it says, according to your equation, what will the population of Johnson City be in the year 2020? So can we just plug in 2020? We've got to subtract. So how much time has passed from 1995 to 2020? So what are we plugging in for X? 25. So type that in your calculator. Plug in 25 for X. Let me know what you get. And again, we're talking about people, so let's go ahead and round this to a whole number as well. 5494, and then it's, I have like 5.5. Yeah. So should we round to what? There we go. Is that okay? Yeah? Is this pretty easy? Yeah? Okay. I haven't lost anybody yet, have I? Alright. So looking at the next one, Mr. Smith bought a house for $96,000 in 1993. The real estate broker indicated that houses in his area are appreciating. So appreciate means increasing at an average annual rate of 4%. So what will be the value of Mr. Smith's house in 2009? So I want to write our rate and our factor first. So what would your rate be? 4% as a decimal? Is that okay? If you're not sure how to convert a percent to a decimal, your calculator will do it for you. Do y'all remember that percent button that we used yesterday in our homework? Yeah. So if we do 4 and then hit that button again, so it was the question mark beside of G, and then we select percent. You just hit enter there. Well, it made it a fraction because it's a fraction. Control enter, it'll give it to you as a decimal as well. So you can do it that way if you're not sure how to convert, because sometimes we have decimals there and it gets a little confusing. So if you need to do that, you can. What would our growth rate be? Or not our rate, our factor. That's where I found the rate. Remember, that's when we add 1 or subtract 1 if it's decay. So 1.04. Is that all right? Are we like starting to see the difference between the two? Yes. So when we go write our equation, we're going to have y equals. And what did we start with? What was our initial amount? Yep, 96,000. Then what goes inside parentheses? 1.04, whatever your growth or decay factor is. And our exponent, if we're just writing the function, would be x, but we can go ahead and plug in whatever we need to figure this out. So we want to know the value of the house in 2009. So from 1993 to 2009, how many years have passed? So x is going to be 16 for us. So you can go ahead and plug 16 in, type that in your calculator, and we'll see how much that house is worth. Now it's dollars, so we don't necessarily have to round it to a whole number. We could do 2 decimal places. I think it does a whole number anyway. So what do we end up getting there? Okay. Okay. Questions? Alright. Moving on. So those are all growth. Now we've got decay. So what's the only thing that's going to be different in our equation? Minus. So you're going to have y equals a, and a is still your initial amount, 1 minus r, and r is being your rate, to the x. So all this stuff off to the side is still going to be the same too. So on the front, what did we say that y was? Your dependent variable. What is your A? Good. And that B value, we don't have a B over here, but where do we look to find that? Inside your parentheses. And what is that number inside the parentheses called when we do 1 minus your rate or 1 plus your rate? Your factor, so it would be decay factor this time. Is that okay? And then what is X? Your independent variable. And what is X usually for us? Time. So the last thing I want to add is R. So what is R? Your rate. And we're going to write it as a decimal. And that's that. We all right? Questions on anything? Are you ready to try some?
Yeah.
Okay. So I think the decay ones are just a little bit trickier only because you have to subtract. But everything else is still going to be the same. So the original price for a tractor is $45,000. The value of the tractor depreciates, so that means decrease, at a steady rate of 12% per year. So what is our rate going to be? 12%, write that as a decimal. Point what? Is that okay? How are we going to find our decay factor? So 1 minus that rate. So I like to think of like 100 minus whatever. So 100 minus 12. What's that going to give us? 88. So your decimal there is just 0.88. Is that okay? Question? All right, so let's go ahead and write our equation. You're going to have y equals. Why are we putting 45,000? It's your initial, that's what you start with. Inside parentheses for our decay factor, what are we putting? 0.88. And your exponent will be an x. For the next part, we want to know the value of the tractor in 5 years. So how are we going to find that out? Plug 5 in for x. Yep, so do that right now. Let me know what you get. And this is talking about the value of a tractor, so how many decimal places should we go? 2, okay? What do we end up getting? 747. Questions? Did we all get there? Yeah. Moving on to the next one. So a new Honda Civic cost $18,000 in 2009. It is expected to depreciate in value by 12% each year. So how much will the car be worth in 2015? So that word depreciate tells you that it's decay. So we'll start by finding our rate. What is our decay rate going to be? 12% as a decimal. How do you write it? 0.12 or 0.12. Then for our decay factor, how are we going to find it? 1 minus 0.12. So we're thinking like 100 minus 12. What do we get? 0.88. Then we can go write our function. We're going to have y equals. And what do we start with? 18,000. That goes inside parentheses. 88. And what's your exponent? It'll be x. We're trying to figure out how much the car is worth in 2015, and he bought it in 2009. So how old is the car? Or how many years have passed? 6. So what are you plugging in for x? 6. So do that right now. Let me know what you get. So after we plug all that in, what do we get? Did we get there? Alright, so next one. The population of Detroit was this number. In 1950, the population has been decreasing by 1.5% every year. So find the population of Detroit in 2009. So what is our decay rate going to be? 1.5%. So convert that to a decimal. What would it be? .015. Is that okay? So we've got to move that decimal 2 places to the left. Then for your decay factor, how are we going to find that? So 1 minus your rate, so 0.015, and what do we get? Okay. Yeah? Did we do that in your calculator? And if you didn't, you should. So then from there, we can write our equation. So you're going to have y equals, and then we've got to put our starting amount, so that's that big number up here. What goes inside our parentheses? 0.985, whatever your growth or decay factor is. To the, let's figure out what exponent we need. So we started in 1950 and we want to know the population in 2009. So how do we figure that out? How many years have passed? 59, right? So we'll plug in 59 for your exponent, type all that in your calculator. Let's see what we get. And why do we round to a whole number this time? People. Is that all right? Questions? Are we bored to tears yet? Maybe. Are we bored to tears yet? Yeah. Huh? We're okay? Alright, so we're almost done. I'm sorry, I feel like y'all hate your life. Oh, good. Okay, so the next section, we want to determine if it's growth or decay. And then it's going to ask us for your rate of growth or decay. So for this function right here, is it going to be growth or decay? Why is it growth? That number inside parentheses is bigger than 1, so that means growth every time, right? So we know it's growth. So what was the rate? What was the growth rate? How are we going to find that? Minus 1 from whatever they got going on in here, right? Because we know that it was 1 plus something gave us that number. Do you agree? So I'm going to write that. 1 plus your rate gave us 1.35. So what did they add in? the 0.35, convert that to a percent. Could we do that? So you could say it's 0.35 or what? 35%. Is that okay? So the growth ones are easy, right? Do you have questions on that? Pretty straightforward. So for B, is this function growth or decay? Why is it decay this time? Because that number inside parentheses, that growth or decay factor is less than 1. So the decay factor is smaller. We want to find the rate of decay. So we know that they did 1 minus something to get 0.72. Do you agree? So how are we going to find that something? You could add 1 to this. That's the easy way to do it. You could do 1 minus 0.72. You could solve this equation for R. I really don't care how you do it. You do whatever you like best. Figure out what they had to subtract from 100 to get to 72. You could count up from 72 to 100. So 72 plus what gets you to 80? 8, and then 80 to 100. So 28.28. Is that okay? So if it was 0.28, what percent would that be? Questions? So those are like really similar stuff that they may ask you, like especially on your tests, quizzes and whatnot. They'll ask you to find that growth or decay rate. So are we good on how to do that? Yeah? Okay. So let's look at the next ones. We're almost done. So number 1, when Robert was born, his grandfather invested $1,000 for his college education at an interest rate of 4.5% compounded annually. Use the growth formula right here and blah, 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 all that stuff you know. Write the equation which models the amount in the account. Do we need to do any of these together? Are y'all ready to try the rest on your own?
Yeah.
Yeah? Okay, let's do that. And I'll pull sticks for who's going to answer. That sound good? Okay, cool. Oh, we're going to do that. You can do the rest of that page on your own. There's nothing on there that you don't know how to do now. What? Are we sure we're ready?
Yeah.
Is there anything just looking at you think you might have a question on? Did you say it's what? Are we complaining about the sticks or that it stinks? The sticks. I really thought somebody just said it stinks. And I was like, oh my gosh, I'm sorry. Anyway.